Very easy introduction because I'm the next speaker, so I get to introduce myself. We'll just give a minute for people to leave the room. So what I always find interesting about introducing my background is that I'm not a technologist. I'm actually a CPA, so an accountant. I've spent most of my career either being an auditor or a consultant, but usually all around the risks of technology. And so about 6 years ago, I started to get involved, moving from clients that were using robotics process automation, now wanting to have more cognitive robotics, and so moving into the use of machine learning. And a lot of it initially involved using natural language processing, but we're really starting to see the evolution of AI being used in different corporate and government applications. So what I wanted to today is maybe build on a little bit of Mark's conversation to go through a blueprint of some of the leading practices that I see in working with organizations and governments on really what is some of the ways that you can try and move some of the theoretical concepts about responsible or trusted AI into reality. Because what I find is that I've spent a lot of my time dialoguing with regulators, standard setters, industry associations, corporations, governments, and there's actually quite a significant consensus on what we want responsible or trusted AI to look like. We want it to be unbiased and fair. We want there to be appropriate transparency. We want it to be working the way it's intended. But what we find is that moving from those principles into reality is very challenging. And part of the reason why it's challenging is because we can't move away from principles, because every use case of AI has a different context. It has a different data set that's being used, a different algorithm, a different set of outcomes. And so, if you look at a use case like lethal autonomous weapons, you can create some prescriptive rules and laws. But when you start to try and generalize that across all the different types of AI use cases, you're looking into healthcare, looking into education, finance, it's really difficult to become prescriptive. And so that's why you find that a lot of the regulations and standards that are being proposed are all focusing on what I'll call a risk-based approach. So what they're basically is asking whether it's the operator or designer of the AI system to do a risk assessment and then to categorize this. Is this a high risk or a low risk? And depending on that risk assessment, you then have to decide on this set of governance and controls. So they're trying to be more prescriptive to say if it's high risk, then you should have an independent validation of the outcomes of the AI model. You should have stronger governance practices in place. And that's kind of the basis of the EU AI law and a lot of others that are coming through. But it's really difficult for corporations to really get that risk assessment right. And so when I speak to organizations about how to put in a good structure of AI governance and controls, what I tend to focus on is a concept that we at EY built. It was actually for other technologies, but I've coined it for AI as well. It's called trust by design, which is very similar to privacy by design, which is really focused on really trying to think about the principles of trust or responsibility or accountability at the very beginning stages of building an AI model. And the first stage of that is the problem statement. There's been a couple of times today that different speakers have brought up the concept of AI for good. And I associate that with the United Nations. I was at their first conference for AI for Good back 5 years ago, and it was really trying to see how could we use AI to do good, to help the UN accelerate its achievements of its sustainable goals. And getting to AI for good really starts with us deciding what problems do we want to solve. Do we want to solve problems that create profits for corporations or that enhance public good? And so the very first step in getting to AI for good is selecting what problems we're going to solve. I like to kind of also coin with that a second term, which is AI for better. And the reason I say AI for better is because AI for better is also about, can we try to use AI to create a better society than we have today? There's a lot of dialogue about the inherent biases within data and decisions from the past. But we can use AI for good, not to magnify those because they exist in the training set that it's being trained on, but to actually counteract, those biases and those historical inequities. And so really that problem statement is, the first opportunity that we have to start building AI for good, as well as creating a broader objective function to get AI for better. So an example would be there's a lot of dialogue around the use of AI in recruiting applications. And the concern being that a lot of times they're using optimization engines, which based on historical data would say, well, my historical candidate was a Caucasian male. So it will look for candidates that meet that historical, most employed individual. But what if instead you said, okay, I want not to get the ideal candidate, I want a diversified workforce. So AI's objective function is not about finding the ideal candidate, but to create a diversified workforce. It then is going to start to actually look to create a team and not just a particular individual. It'll then pull different candidates that create some diversity within the workforce. And so you will have a very different outcome for that one objective function versus the second. And so that's, again, the power in defining your problem statement and thinking about how you can achieve broader objectives than maybe just the singular functional one, but embed ethics and responsibility into that original problem statement. When you're building AI, the next stage that we tend to think about is designing it. So, this is usually tabletop design before you even get into prototypes. And this is a very important stage, I think, in building into ethics, because this is where you can actually create design challenge sessions. And what I call those is where you bring in a lot of different people that have a lot of different perspectives. You're going to have focus user groups. You could have ethicists, socialists. You could have people who are against the technology you're trying to build, as well as the champions who want it. So you bring a whole bunch of diverse people who can actually dialogue and debate with each other. And I've always said that you'll know you've done these design challenges well if you walk away from the table with a big rock in your stomach, that you're feeling uncomfortable because there was some uncomfortable conversations at the table. There were scenarios about people dying from your AI or being financially or inequities creating from that. If there's scenarios that people can think of how this particular AI model can create harm, whether it's to the environment, animals, or humans. Or where, they just don't think you can control the outcomes, or there isn't the strongest monitoring systems to monitor its outcomes. So these design challenges sessions really should make you feel uncomfortable. But hopefully, the second, third, or fourth, or fifth time you meet, you're actually starting to actually pull together responses to those uncomfortable issues. Maybe you decide to kind of put some boundaries around the AI model, or you recognize you need a whole different data set, or you need to, go back to the problem statement and change it. And so that's kind of, from a design perspective, thinking through all those different scenarios so that the outcome of what you're going to have is actually going to be far, far better than when you start. Then you get into data collection. And the thing with data collection is that when I first started in my role 5-6 years ago, the predominant thought around how to reduce bias was to eliminate features within a data set. So remove gender and ethnicity and age. But what was found is that it's very difficult to remove all the correlations in data that, looking at resumes, that, women use different words than men, or it could be correlated that I was a woman because of the woman related sports that I was in, or the hobbies that I have. And so AI is really good at correlating gender and sometimes ethnicity based on postal codes and where people live. And so what's becoming more predominant now is to leave those features there. Don't change the raw data, but really analyze the data and understand what kind of historical biases and inaccuracies and incompleteness exist within it, and find ways to remediate for that. It could be through the objective function. It could be through coming up with alternative data sets. But recognize that once you move out of training and modeling into production, those historical biases are still going to sit within that data set. So is it not far better to try to recognize what biases are there, remediate for them as part of the training process versus data cleansing. Because it's really difficult to keep up with data cleansing, and it changes the data set. So if you want to now use that data set from a finance application to healthcare, as we start to see more fields in different industries merge together, we're going to want to have a raw data set that hasn't been tampered with. Because if I want someone to use a data set for a healthcare decision, I want them to know I'm a woman, because that can have some differences in how I'm going to respond to different treatment plans, or how different symptoms might manifest for different diseases. And so it's thinking through how can we sustain the use of AI, and that would be one way. You then get into the operation of AI and thinking through putting it into production. And there what we're finding, and what I'm very happy to see, is that the academic institutions and some of the technology leaders have really started to put a lot of investment into the monitoring and testing and oversight of AI, because that was really lacking when I first got involved 5 or 6 years ago. And the reality is that we as humans are very poor at overseeing AI. It operates far too quickly. We get bored. And so we really need to devise automated mechanisms to check the AI for certain boundaries. So AI today is called narrow AI because it operates within a very narrow function. And that narrow function can be defined, and we can create boundary conditions where, as the AI starts to drift across those boundary function or conditions, we can actually create some red flags. And what we can do is adjust the way that we are designing the AI. We can maybe pull it back, do some retraining. We can recognize there's been some changes in the overall environment that it operates, or the data sets that it's using. And so it's an opportunity for us to then quickly identify that some harm could start occurring, and pull that back. What we also have to recognize is that AI is a different technology than all the other technologies we've used, with the exception of any other analytic model. So all the other technologies are rules-based. So we've predefined before it went into production how it's going to operate. AI by its design is a probability-based system. And so what that means is that based on the way it's been trained and designed and the information it has, it will come up with an answer. But that answer is the best answer that it can come up with within the conditions that it's operating. It doesn't mean it's the right answer. And so a lot of, I think, the challenges with AI is that we don't go in expecting it to fail. We don't go in expecting that it's going to have some wrong answers. We don't go in with the expectation that it's not going to be able to operate as soon as its, environment or the data changes. And so we're not prepared when it fails. And so I think the biggest thing that each of us can do, whether what your role is within AI, is to educate yourself so that you can start predicting how AI is going to fail. We as humans, this comes up a lot in this dialogue, we fail. We get things wrong. But we have all operated so long with humans doing these kind of processes that we actually do have a lot of capability to predict when we're going to fail, when we're going to be biased, when we're going to make errors. If I'm tired, I'm going to make errors more than if I'm not. Like, we actually all have a preconceived set of conditions that we know how to predict when humans may err. And we need to start building that same knowledge resource for artificial intelligence. And that should hopefully allow us to build more trust into the technology, because although I spend a lot of my time talking about the risks of AI and how it might fail, I do it because I'm actually very bullish about using the technology. I want to see AI for good or AI for better. But we can't do that if CEOs of corporations won't put enough investment money in because they're concerned it's going to create reputational damage, or even financial damage, or AI developers aren't getting the full support from privacy and risk and control specialists within the firm because they don't understand the technology. So I do want to make sure that we can accelerate the use of AI, but we're going to have to do that by having it trusted. So that's what I wanted to talk about today. I think I've got time, 5 minutes. Sorry? Yeah. So I wanted to end on that and just see if there might be any questions from the group that I could answer. There's a question right there. And then one in the back.
Thank you. My question is more into, we all understand that there's some bias and we need to kind of make everything a little bit more trusted. However, many of the corporations that basically we all work with, they have constraints in terms of return of investments of the algorithms that we're building, right?
Yeah.
So if we put a time on modeling on an iterative environment that we're living for, and also on the training of the data, then how that can correlate with the return of investment, right? So you would not have enough time to actually model the risk. You would not have enough time to actually understand on the training data that you are inducing bias or introducing bias. How can these two things correlate or live together from your perspective of consultancy?
Yeah, so I think that's a really good point. We all have to appreciate that most of AI is being sponsored by corporate dollars, and they have different priorities, returns on investment that they need to see. And one of the challenges is that AI is not living up to its return on investment promises. And so the very first thing I would say is be very, very strategic on what you choose to use AI for in those first couple projects, because that is going to create a lot of first perspectives about AI. And so really try and choose those against a couple of criteria. One would be you do already have the existing data set. Two, that there actually is a return on investment from the AI that actually is aligned with the corporate objectives and priorities. And so there may be some pet issues that you have or areas of interest, ignore them. Because instead what you're trying to do is you're trying to build support. And the best way to do that is to pick something low risk but high value that's easy to do very quickly so that you can build that trust. Because eventually, once you've got that trust built, you'll get the larger dollars, you'll get the greater support, but not if the first couple take too long, don't have any real tangible return on investment, even though they may have other benefits. And so that would be work within that environment and be very strategic. Then you can, once you've built that trust, also look for a champion. Look for someone who's very innovative, maybe a head of a department or a business area that is really willing to step out for you and really work with them too on some viable use cases. So I know we had another question in the back.
Hi. Hi, thank you for the talk. My question was regarding the thing you mentioned about setting boundaries and flagging when AI predictions drift across those boundaries as a way of ensuring trustworthiness. Could you elaborate or perhaps give an example of what such boundaries might look like in different use cases?
Yeah, so I find that any type of technology usually has some kind of operational expectations. How available is the system? How long time does it take to process? So, measurable indicators that you can use to identify if something is operating within the intended expectations. So the thing is to design those similar type of measurements for AI. So if you look at just a simple recruiting application, it could be that there are a lot of ways to measure bias, right? And so you can look to see, are the outcomes too heavily weighted to a particular gender or ethnicity? Are they distributed across the population by age? There's also some tools that will actually allow you to actually visually see, with all the data sets that have been given to an AI model, which one it actually uses, right? And what can be really interesting is you can see that it's actually only relying on a very small set of clusters of data sets and could be ignoring 75% more of the data. So if you look into what is the 75 it's not looking at, you may identify some patterns where there's some, certain data features it's not utilizing. You also can look at the change in the operation of the AI as it moves through time to see how its outcomes from various different distributions are changing. I'm not a data scientist myself, but these are just some of the examples that I've been given. So it really is eventually trying to model the behavior you're looking for the AI and find some ways to know this doesn't quite look right, to get some yellow flags and then hopefully, very identifying what those red flags might be. So I think that's the end of, unfortunately, my Q&A. I will be here later if you guys want to speak about it further.